Hello my dear friends of electronics. My name is Lorandt and I will show you in this video what is the meaning of different capacitors in output on the DC-DC converter. We have here 3 times the same DC-DC converter, always with 1 MHz switching frequency, but we have different output capacitors. On the first one we have 2 times 47 microfarad aluminum capacitor. The second one has a 47 microfarad polymer capacity in parallel with 4.7 ceramic one. The third one, it is only a 4.7 ceramic and the 47 microfarad ceramic as well. On input, we will connect to the external source like a 12-volt DC converter, and then we will have an output 5-volt 1 amp, and the 1 amp I choose here at this time some resistors, just a standard high current resistors to have a constant load. And first of all we will try the first DC-DC converter, switch on the power supply, the LED is lighting, it means we have the input voltage. And first what we have to do is to unwear this pigtail from the scope probe, and because we are wanted to measuring some small millivolts, I will recommend never use these pigtails, use this small spring. So let me see how much millivolt ripple current we have now on the in output. Okay, watch out to trigger that right, stop the trigger. Now we can see by the cursors our output ripple voltage, it is by 220 millivolts. That's quite a lot. For a 5-volt output, 220 millivolts ripple voltage is quite a lot. So we should try something better, and for this reason I will switch off to connect the second DC-DC converter, which is have all the same topology, absolutely identical, just the output capacity is different. Again, 1 MHz switching frequency from an LT chip. On input, a nice P filter for filtering the EMI on the input, and now LED is on, and let me see what is the ripple voltage now on the output. So it looks much better. I would even say quite not bad, because we have now a ripple voltage roughly by something 25 millivolts. So 25 millivolt in comparison with 220 millivolt, it's a lot. So this time we have a combination of MLCC and a polymer 47 microfarad and 4.7 microfarad for the MLCC. Now let me try the third one, which has only just ceramic capacitors, so MLCCs. LED is on, and what means if we have only ceramic 47 and 4.7 MLCC? Let me try to put the ripple again. Now cursors again. The ripple voltage did increase a little bit to 28, so from 25 to 28, of course, because the MLCC in this time we are using a 5-volt DC output, and the MLCC, like a ceramic capacity with a DC bias, it will drop. It's not anymore 47 microfarad. So that's the reason why I assume that a better combination, and I recommend the best combination, to use a polymer with the MLCC in parallel. That's always the best option. If you just use MLCCs in the output, it could be dangerous because of the DC bias load, which I explained in another video, which I recommend to watch as well. And it will drop a little bit, and maybe even more. It depends always on the voltage selection. But anyway, the best choice is to polymer and MLCC in parallel. I hope you enjoy it and you have fun, and please watch my next video. Bye bye.